on prime and composite numbers. Let's start off with what the definition of a prime number is. Prime numbers have exactly two factors, so let's write that down. Prime numbers have exactly two factors. Exactly means no more than 2, no less than 2. And let's start by looking at some examples. The number 2 has exactly two factors, 1 times 2, so I'm going to make a list, 1 times 2. The number 3 has exactly two factors, 1 and 3, because 1 times 3 is 3. I'm going to skip 4 because that has 1 times 4 and 2 times 2. So my next prime number in order is 5 because it has two factors, 1 and 5. 1 times 5 is 5. The next example of a prime number after 5 wouldn't be 6 because 6 has 1 times 6 and 2 times 3. So the next one is 7. Its factors are 1 and 7. 8 would not be prime because it has factors 1 times 8 and 2 times 4. 9 would not be prime. 10 would not be prime, so my next number on the list that's prime is 11. Its only factors are 1 times 11. So on my list, I write 1 and 11. 13's the next one, 1 times 13. 14, 15, 16 are not prime because they have more than two factors. So next on the list is 17, and 1 times 17 is 17. So that's a short list of prime numbers. They can go on and on infinitely. Let's look at a different kind of number called a composite number. The definition for a composite number is it's a number that has more than two factors. So a number that has more than two factors. So let's look at our example. If we look at our prime numbers, we started with 2 and went to 3. So the next number would be 4, and if I listed all the factors of 4, I know 1 times 4 is 4, and 2 times 2 is 4. I'm only going to list the 2 one time. So the list of factors is 1, 2, and 4. That's more than two factors, so that's what makes it composite. Next after 4 is 5, which I can see is already on my prime list. I'm going to list 6. Its factors are 1 and 6. 1 times 6 is 6. And 2 and 3. 2 times 3 is 6. So 6 has 4 factors. Next on, if I went in order, I'd be thinking 7, which is already prime. Next is 8. Has more than two factors, 1 and 8, 2 and 4. Let's take a look at 9. Some people think 9 is prime because it's an odd number, but that's not true. Some odd numbers are prime, but not all odd numbers because it has 3 factors, 1 and 9, and then 3, because 3 times 3 is 9. 10 is even, and you'll notice most even numbers are going to be prime because 2 will always be a factor of an even number. If I listed the factors of 10, I have 1 and 10 and 2 and 5. If you notice in my primes, though, 2 is going to be the only even prime number. The rest of the even numbers are all composite because they will have 2 as a factor. Okay, some people like to ask, where's 1? What about 1? Let's think about the number 1. How many factors does 1 have? We know 1 times 1 is 1. So if I were to make a list, there's the factor of 1, 1. So does it fit under the definition of a prime number? A prime number must have exactly two factors. Well, 1 only has one factor. Let's look at the definition for composite numbers. The definition is a number that has more than two factors. Does 1 have more than 2? No. So it fits neither definition. So the answer for 1, is it prime or is it composite? It's neither prime, neither prime nor composite because it does not fit either one of those definitions. So it's basically just a number. We can call it a counting number. We can call it a natural number, but it's not prime or composite. Let's take a look now at prime factorization. Okay, so we know what prime numbers are and composite numbers are. Prime factorization means we're going to take a composite number and break it down into its prime factors. So we start with a composite number. 100 is composite because it has more than 2 factors. I'm going to break it up into 2 of its factors. It can be any 2. If I were to list all the factors of 100, 1 times 100, 2 times 50, 4 times 25, 5 times 20, and 10 times 10, I could start breaking 100 up with any of these pairs of factors. Not 1 times 100 because I'm just going to end up with 100 again. So I'm going to choose 2 times 50. So I know 2 times 50 is 100. Now as soon as I see one of those is prime, I'm going to circle it. I am done. So 2 is prime because it has exactly 2 factors. 50 is composite because it has more than 2 factors, so I'm going to split up 50. I could split 50 up into any pair of factors I want. So if I were to list all the factors of 50, 1 times 50, 2 times 25, 5 times 10, I think that's all of them. I may have missed some, I'm not sure. But I could pick any ones I want to start with to break up 50. So I'm going to pick 5 times 10. So what are 2 factors of 50? 5 times 10. I'm going to look and see if one of those are prime, and if it is, I'm done. That's the prime factor. And then I'm going to look at the number 10. It's composite, so it still needs to be broken into its prime numbers, its prime factors. So 2 times 5 is 10. Is 2 prime? Yes, circle it. Is 5 prime? Yes, circle it. Now I'm going to write it here at the bottom. What is the prime factorization of 10? I'm going to start with the lowest numbers I have here. 2 times 2 times 5 times 10. And if I were to go back and remultiply all these prime factors, I should get 100. So let's try. 2 times 2 is 4. 4 times 5 is 20, and 20 times 5 is 100. So 2 times 2 times 5 times 5 is called the prime factorization of 100. I can also write this with square numbers, exponent form. So I can say 2 to the second power times 5 to the second power. All right, that's it for now. If you want to try 48 on your own, go ahead and give that a try.